What if your network security was failing because of one misunderstood setting? Wildcard masks look like subnet masks, but they work completely opposite. In this video, I'll show you how to master wildcard masks for ACLs and OSPF, plus a simple trick to convert subnet masks in seconds. Want to stop guessing and start configuring with confidence? Let's dive in. ACL and Wildcard Mask. An ACL is a feature of Cisco iOS that is used to identify traffic. It allows a network admin to create a set of rules that will either allow or prohibit any type of traffic based on the information contained in the IP packet. They can be used on routers or switches. The ACL works in sequential order. The packet header is parsed by the ACLs, one after the other, from top to bottom. If one ACL matches the packet, then the rest of the ACLs will be ignored. The package is then either allowed or denied. If the packet header does not match the first ACL line, then the packet is tested on the second line and so on. This process continues until the last ACL, and the last ACL in the list is called an implicit DSI ACL, which systematically denies the packet. If none of the ACL match the IP header, then the packet will be dropped for security purposes. To use certain protocols or router features, wildcard masks are sometimes used. This helps identify a subnet or range of IP addresses. The OSPF routing protocol and also NAT use wildcard masks. Wildcard masks are used to identify addresses that do or do not meet certain criteria, i.e., based on an IP range. When applying a wildcard mask, keep in mind that a bit with a value of 0 checks for address matching, and a bit with a value of 1 ignores the corresponding value of the address. To understand this, let's take an example. We have the 168.1.1.0 network within wildcard mask in 3 times 0, 63, which corresponds to a 26. For each address, I have given you the decimal form and the binary form. Each bit of the address that corresponds to a bit at 0 in the mask will have to be identical to match the network. In this example, only the last 6 bits of the address can vary. All addresses that start with the binaries shown in green will therefore be part of the IP range. That is to say, from 0 to 63. So even if I know that now you are unbeatable in binary, I will like to show you a technique to calculate wildcard masks faster. Generally, wildcard masks are used that correspond to subnetworks. For example, a wildcard mask in 4 times 0 corresponds to a normal mask of 4 times 255, a 32. In this case, the mask matches only one address. A wildcard mask in 3 times 0, 63, corresponds to a normal mask of 3 times 255 192, that is to say, a 26. 3 times 0, 255, corresponds to a mask at 24. 3 times 255.0, 2 times 0, 2 times 255 returns to a mask in 16, 2 times 255, 2 times 0, and so on. To quickly calculate the wildcard mask, the easiest way is to make a simple subtraction of 4 times 255 by the normal mask that we want to convert to wildcard. 255 minus 255 gives us 0. 255 minus 192 facts, 63. And 255 minus 0 equals 255. To finish this introductory course to ACL, we will see the 2 types of ACL that exist. We have standard ACLs that allow us to check the source addresses of packets that can be routed. They are numbered from 1 to 99 and from 1300 to 1999. In general, They will be applied as close as possible to the destination because of their low accuracy. And we have the extended type ACL that allow you to check the addresses of the source and destination packets. They can also target specific protocols, port numbers, and other parameters. This gives admins more flexibility and control. They are numbered from 100 to 199 and from 2000 to 2699. Extended ACL are rather to be applied as close as possible to the source.